Hello, and welcome to another session of Dell Networking. My name is Humair Ahmed, and I'm a Senior Technical Marketing Engineer at Dell. Today we're going to take a look at the Dell FC Flex IO module for the Dell MXL IOA blade switches and step through a demo on FC Flex IO module configuration and deployment. Now, as you probably know, the Dell PowerEdge M1000E chassis is Dell's server blade chassis system that can also, in the back, house up to 6 blade switches within 3 unique fabrics. The Dell FC Flex IO module is a significant addition to the Flex IO module offerings for the Dell MXL and IO blade switches because each module adds up to 4 fiber channel ports, or 8 fiber channel ports if you use 2 modules, to each switch and allows for LAN and SAN convergence at the blade level. The FC Flex IO module transforms the MXL and IOA blade switches into NPIV Proxy Gateways, allowing them to bridge Ethernet and Fibre Channel via FCoE. Pretty cool stuff, so let's go ahead and dig in. So the Dell FC Flex IO modules with 4 Fibre Channel ports, when inserted into the Dell MXL or IOA blade switch, allows you to converge your LAN and SAN traffic. It optimizes and simplifies your network for converged traffic with data center bridging, and it allows for the bridging of Ethernet and Fibre Channel at the blade level, not only providing a converged network, but also a converged infrastructure. Along with consolidation of hardware, the FC Flex IO module provides flexibility in that it can be utilized in conjunction with other Flex IO modules, like the 2-port 40 gigabit Ethernet module, 4-port 10G-based-T module, or the 4-port 10 gigabit Ethernet SFP Plus module. Finally, in addition to cost savings in terms of hardware consolidation, power, and cooling, the FC Flex IO module also decreases IT management costs. We're going to step through an example deployment, but before we do that, let's step through exactly how the topology or network is transformed when using the Dell FC Flex IO module. Our objectives today are to understand the converged topology and benefits, and within a converged infrastructure, configure a Dell MXL blade switch with FC Flex IO module. Also, I just want to mention to check out the Dell FC Flex IOM white papers on Dell.com. So let's take a look at some topologies. On the top left of the slide, you can see a FCoE deployment with a converged switch such as the Dell S5000 bridging Ethernet and Fibre Channel at the top of rack, and the Dell MXL blade switch being used as a FIP snooping bridge or FCoE transit switch. The internal links from the CNA to the MXL and the Ethernet links between the MXL and the converged switch carry the converged traffic up to the converged switch, which then has both Ethernet and Fibre Channel ports and can separate out the Ethernet and Fibre Channel traffic. On the bottom right, you can see that the convergence layer has been brought down to the blade level with the introduction of the FC Flex IO module. Here you can see that the converged traffic is all internal, and the LAN SAN traffic breaks out right at the blade level. The FC Flex IOM adds 4 Fibre Channel ports to the Dell MXL and IOA blade switches and transforms them into an NPIV Proxy Gateway, allowing to now bridge between Ethernet and Fibre Channel. The benefit is that a top-of-rack converged switch is no longer required, and you don't have an FCoE transit switch in the middle, cutting down the number of switches and cable requirements. So here we get not only a converged network, but a converged infrastructure with further consolidation of hardware. A better comparison is actually with a non-converged blade solution and a converged blade solution. Here you can see a non-converged blade solution. So we have a server with a NIC in the Fabric A slot of the server and a HBA in the Fabric B slot. Respectively, we then have MXLs in Fabric A of the M1000E chassis and Brocade M5424 Fibre Channel blade switches in Fabric B. Of course, the MXLs are used to carry the LAN traffic, and the Brocade M5424s are used to carry the SAN traffic. When we look at the next slide here showing the converged network with FC Flex IOM, you can right away see the benefits of a more consolidated infrastructure with less blade switches and adapters consuming less power, but also less maintenance and management points. Before moving into the actual topology and configuration, I just want to mention that the deployment of FCoE on a network can pretty much be summed up in 3 steps. 1. Configure the CNA. 2. Configure the MXL or IOA blade switch with FC Flex IOM. And 3. Update or create the appropriate FC zoning and storage information. In this video, we're going to focus on step 2. Steps 1 and 3 require minimal work, and if interested in seeing a demonstration for these steps, check out the other Dell networking videos in regards to FCoE. You can find videos on Dell's top-of-rack converged switch, the Dell S5000, that go into details on steps 1 and 3. Here's our topology for this lab. Starting from the M1000E chassis, I have an M620 blade server running Windows Server 2008 R2 Enterprise. The blade server is utilizing a 2-port 10 gigabit Ethernet QLogic 8262K mezzanine CNA adapter. The converged traffic is represented by gray cables. And this is actually internal to the chassis, so there wouldn't be any actual physical cables here. I displayed it this way just for demonstration of where the traffic converges and breaks out. The CNA on the server is connected internally to internal 10 gigabit Ethernet ports on the MXL switch. You can see the Ethernet and fiber channel traffic break out at the MXL blade switch. The LAN traffic in yellow is sent out the 40 gigabit Ethernet ports to the LAN S6000 switches. Note here that Dell's 6000s are running VLT and connect to the 40 gigabit Ethernet ports on the MXL with that VLT lag. Dell's VLT technology allows for a lag to connect to 2 separate upstream switches while keeping both the links active. The fiber channel SAN traffic in purple is sent out the 8 gigabit fiber channel ports of the FC Flex IOM module to the back-end fiber channel switches, which in this case happen to be Brocade 6505 fiber channel switches. Each fiber channel switch is connected to fiber channel ports on the Dell Compellent Fiber Channel Storage Array, consisting of 2 SC8000 controllers and 1 SC220 storage enclosure. 2 ports from each fiber channel switch are connected to 2 ports of each storage controller, providing for redundancy at the fiber channel switch and controller level. One last thing to mention is that the CNA is set to active standby for LAN traffic, while the SAN traffic behavior is guided by the MPIO policy you set with the MPIO software provided by the storage vendor. In this case, I'm using a round-robin multipathing policy, so both fabrics will be utilized and I'll still have the redundancy required. In this setup, we're going to configure the Fabric A MXL blade switch with FC Flex IOM so that the server 4 has access to the marketing disk volume on the compellent storage array. Let's go ahead and jump onto the CLI. The first thing I'm going to do is enable Rapid Spanning Tree Protocol, and I'm going to do that because I have VLT running on my Dell 6000 switches upstream. It's best practice to enable RSTP when you're connecting to a VLT lag like we're doing in this case with the 40G033 and 40G037 ports on the Dell MXL blade switch. Now, as I mentioned before, both links of this lag will be active or non-blocking due to Dell VLT technology. Next, what I'll do is create a LACP lag with the 40G033 and 40G037 ports. That's connecting to the VLT lag coming down from the S6000s. And I'll go ahead and use the interface range command so I can apply the same configuration easily to both ports. Next, I'll create a LAN VLAN and tag the respective interfaces. First, I'll go under the port channel I just created, port channel 10, and I'll put it in layer 2 mode with the switchboard command. The reason I'm doing this is because later I'm going to tag it on VLAN 5, which is my LAN VLAN. I'm sending my LAN traffic tagged on VLAN 5 from my server. Next, I'll go under my interface connecting to my server, which is the 10G04 interface. I'll do no switchboard, put it in port mode hybrid, and then put it back in layer 2 mode with the switchboard command. The port mode hybrid command is used on an interface if both tagged and untagged traffic will be crossing it. In this case, this port will carry both tagged and untagged traffic. The untagged traffic will be on VLAN 1, which is the default VLAN, and it'll carry the FCoE control traffic or FIP traffic used to log into the fabric. The LAN traffic will also be tagged on VLAN 5, and once we apply the FCoE map here, the FCoE traffic coming from the server will also be tagged on VLAN 1002. So indeed, this port will carry both untagged and tagged traffic, and therefore we need the port mode hybrid command. Next, we'll create our LAN VLAN, which is VLAN 5. And we'll make sure we tag both the 10G04 interface going to our server and the port channel interface going to our Dell 6000s. And we're done with our LAN configuration. Now I'm going to enable the fiber channel capability with the feature FC command. Now I create the DCB map and configure priority-based flow control and enhanced transmission selection settings for LAN and SAN traffic. Priorities or class of service are mapped to priority groups using the priority PGID command. By default on FC Flex IOM, FCoE is mapped to priority 3. So I'll create the DCB map and name it SAN DCB underscore map. Then I'll create a priority group 0 and give it a bandwidth of 60%. This is actually the ETS settings, the bandwidth here, and priority flow control will be off, and this will be for our LAN traffic. Then I'll create another priority group for our SAN traffic or FCoE traffic of 1 and bandwidth 40% with PFC on for lossless Ethernet. Then I'll use the priority PGID command to map that priority group 1 to the priority 3 or class of service 3 for our FCoE traffic. So priority group PGID 0, 1, 2, and then 3 for FCoE, so I'm going to tie it to priority group 1, and then 4, 5, 6, and 7. And we're done with our DCB map configuration. Next, we'll create our FCoE VLAN, which is 1002 in this case. And we'll create our FCoE map. Now, the FCoE map is used to bind the FCoE ports and the FC ports and map the FCoE traffic to the respective VLAN and interfaces. So here we'll create the FCoE map and call it SAN underscore fabric underscore A. And we'll tie our FCoE VLAN to that with the fabric ID 1002 VLAN 1002 command. Next, we'll assign an FC map, and you can see what the valid range is using the question mark. I'm going to use 0E FC02. Now, the first 24 bits of the FPMA or fabric provided MAC address comes from this FC map. The second 24 bits, also known as the FC ID, comes from the FC switch providing the fabric services, in this case the Brocade fiber channel switch. So this 24 bits plus the 24 bits or the FC ID from the fiber channel switch creates the FPMA or the 48-bit FPMA or fabric provided MAC address that gets assigned to the end node. And now we're done with our FCoE map configuration. So we now just have to apply the FCoE map and the DCB map to the respective interfaces. Let's do the fiber channel interfaces first. And I'm using one FC Flex IOM module, so I have 4 fiber channel interfaces. If I were using 2 modules, I would have 8 fiber channel interfaces. In this case, my interfaces are fiber channel 0, 41 to 44. So I'll go ahead and apply the FCoE map. Do a no shut. And now I'll go under the interface connecting to our server, 10 gig 04. And here I'll apply both the DCB map and the FCoE map. Let's do the DCB map first. And now the FCoE map. And you can see as soon as I applied that FCoE map, a FIP snooping session was created on VLAN 1002. And here's the FCoE map. And you can see this first 24 bits is indeed the FC map we just assigned. And the second 24 bits is the FC ID, which got assigned by the fiber channel switch. So one last thing we need to do. We have to configure uplink failure detection, because if my upstream ports lose connectivity, I want this downstream port to also go down so the failover can happen properly for my LAN traffic. Remember, I'm using active standby configuration. So let's configure uplink failure detection. My downstream port is 10 gig 04, and my upstream port is port channel 10. And I'll also configure the downstream auto recover command. And this basically says enable auto recovery of uplink failure detection disabled downstream port when the upstream port comes back up. So we're done with the configuration. Let me go ahead and save this. Now, to see information on NPIV devices logged into the fabric, you can use the show NPIV devices command. And here you see quite a bit of information. You can see 10 gig 04 is the interface connected to the end node, the FC MAC, the actual fiber channel interface of the FC Flex IOM module that the login and the end node is connected over. And here's the FCoE VLAN. Here's the FCoE MAC address. First 24 bits is that FC map we assigned, and the second 24 bits is the FC ID. You can see here it also gives you the FC ID, and you can see this end node is logged into the fabric. Now you can also see all the FCoE end nodes logged into the fabric using the show FIP snooping enode command. Now if I use the show FIP snooping FCF command, you can see this MAC address, FCF MAC address from this earlier command is actually right here, and it shows you its fiber channel. It belongs to fiber channel interface 044 of the Flex IO module, and you can see there's one login over that module. So you can actually use the show FIP snooping FCF command to see how many nodes are logged in over each of the 4 ports of the FC Flex IO module. Very useful command. So let's go ahead and jump onto the server and take a look and make sure everything is working and we can actually communicate over the converged network. So first I'll send a continuous ping out towards the LAN, and here I have a IP address 5.0.0.10 assigned on this VLAN on Dell 6000. So let's go ahead and send a continuous ping that way. And looks like that's working nice. So let's go ahead and make sure we can actually see the volume on the compellent storage array. And there it is, marketing data compellent. Let's go ahead and just copy over a couple files, make sure everything's working correctly. Yep, and looks like everything's good. Well, that's it for this session of Dell Networking. I hope you found this session useful, and don't forget to check out the Dell FC Flex IO module white papers on Dell.com.